All right, so I'm live with Assimilating PyTorch, and I have my repo here that I'm going to get started with. And if I log right in to a code space, I can get started. So it takes a second for this to wake up. I think last I left off was a Hello World PyTorch, so nothing too crazy. And I'm going to maybe tweak this a little bit. So let's go ahead and create a terminal. So last time I had a command line tool here that was able to download training data from an open data set, download test data from an open data set, create a data loader batch size, go ahead and verify that CUDA was available, which I believe it should be in this particular environment. Define a neural network, create a training loop, create a test loop, and then run it. So I can just run that real quick again. So PyTorch hello world. And I believe one of the things that is kind of fun to test out is to verify that, so it is using CUDA. So this particular example is using the GPU, which is nice. And I think where I wanted to leave off here. So yeah, we don't need to do any more. We know that it works. Is that I wanted to refactor this to make it more of like a command line tool, because that's how I think more, less in notebooks, more command line tools. And so I'm going to actually import. Let's look at the requirements here. Ooh, there's a lot of stuff here. I'm gonna go ahead and use click. So we're going to go ahead and import click. And then I want to refactor this code so that I can change the batch size and also the epochs. I think those are probably the things I would care the most about. So batch size, and then also epochs. So I could just change things. Yeah, so epochs and batch size. So basically we can just say, create a function that or actually let's just go right to click. We'll just say create a click group. Create a click group. Okay, there we go. And we'll say like PyTorch hello world that allows you to change that size and epochs. Exactly right. That's exactly what I want to do. So now we can do that. We can do a click command, and we can just say train, and the batch size will be defaults. Epochs will be there. Exactly right. So now we're going to have to pull in this code here. And I think that Copilot here will make this a little bit easier for me. It is sucky that it has to recreate the entire thing. Although maybe not. Maybe we're okay with this. Let's see here. So we have this, we have this, we have this. Train, create a training loop. Let's see here. Where's batch? That's I see. Well, sure. So let's just nuke this stuff here. We'll get rid of that. And we'll just do it in pieces here. That looks good enough. So now we can just do, invoke this. Wait. A test loop. Test. Let's train. And then epochs. No. Let's check here. So if we go to the code, so we have the data loaders. We check if it's CPU. We create a really quick neural network, and we have a training loop. Training data, test data. So we need to do to basically do the epochs here. Test. A test loop. Not exactly what I was expecting. So maybe I can undo everything here. An easier way to do this would be to already had some working code. I don't want to just take the working code here and just throw it in here for now. Here we go. So we have code that works. Let's just take this code here and let's just nuke this and paste it in there. Now, the one thing we'll need to do is shift everything over. So we'll need to, and I forget how you do this. We can say refactor. Yeah, there's a way to just shift term now. Edit file view go. Boy, kind of a bummer. It's very difficult to know how to shift. Let's just say, let's find out. So we'll say GitHub code spaces shift code right. And shift code, shift or Visual Studio Code. Let's see. Toggle block. Yeah, it's kind of a bummer. It's how hard it is to shift code or tab code. Tab. There we go. Shift right. How the hell do you figure this out? Let's see. Adding commands to move tabs. Let's look at the documentation. Shift command. This is implemented. So, Visual Studio Code. You do how do I indent right in Visual? We select it and you do shift tab. There we go. Boy, that was complicated. Shift tab. Nope, that did not work. We want to. That was exactly the opposite. We want to do. Control to indent. So it would be control and then the open bracket. Control. So, yeah, I'm stuck at the. There we go. So it's actually command open bracket. Wow, that was complicated. So command open bracket, got it. So now I just have to find batch size would be batch size. And we just go to epoch would be epoch. Epochs. And in theory, we would just need to invoke this. Which would be see here, so we have click option would be is it because this needs to be the command train? Is that how it works? I always forget with the groups. There we go. That was the problem. So if I do PyTorch hello help, does that work? There we go. So now I should be able to do train. I can say dash help, and it should have epochs here. Yeah, epochs, and we'll just do one epoch. Epochs. Not bad. Pretty cool. So now I have the ability to tweak this a little bit more. And then if we want to look at the NVIDIA GPU monitoring, see in fact that it was using the GPU right here. So a nice way to just really quickly kind of make a command line tool around PyTorch. So if we say get status, a little longer than I wanted to take, but got it going. We'll say, if I say make refactor, what happens? Can I refactor my code? Yeah, not bad. Refactors it. We could probably tweak this a little bit then. Let's make it cleaner code. So let's see line 83. It says redefine train from outer scope. So train, we'll just change this to be train CLI. What's next here? We have line 42. It says assigning the same variable to itself. Good point. I don't need it because it's passed in. So if we go here, we can say assign the same variable to itself. That's another one. I don't need it because it's just passed in. Port has no float 109. That one, I think we can just ignore self-assigning variable. So we can just put that maybe at the top of this. We can say pilot disable. We can just disable that. Now if I do make lint, so I think I need to put this pilot here. That might work. Yeah, some of these fancy libraries have to be tuned a little bit for linting. Pilot disable 109. Why does this not pick up 109? see this. Maybe I can actually pass this into the actual main make file here. Disable and just do it right here. Yeah, self-assigning variable. No member. So for now, we're just saying int. No module named no member. Disable. Oh, because that needs to be. Here we go. Okay, got it. All right, so we had to tweak things a little bit to get this command line tool working, but we can do make refactor. There we go. And let's status, add all this in. So we'll say hello world PyTorch CLI. Great. So what else can we do here to play around with this code? I would say that I know there's a new PyTorch, right? So what else can we do? Just see what's going on with PyTorch. And we can also serve this out as a model. So getting started and tutorials, quick start. So this is what I did before. I did the quick start and creating the model, saving the model, loading the model. So this would be kind of fun, is we could basically add a function that essentially saves the model on our command line tool. That's possible. That's one thing that we could do, which seems interesting. Let's try that out. So that might be a good one to go next. Is let's because this is the training loop, and if we want to save this thing out, we'll just do torchserve, and the model is there. Where's the model set? Model.train. And we can do save the model. Torch.save. Model. There we go. So I suppose we could ignore this though and git ignore as well, because it's going to be annoying. So let's go ahead and do that. Oh, there we go. It already does ignore it. Great. So let's train one more time real quick. Let's do this one epoch and let's see if it changes. If it saves the model out real quick. It does. There we go. So now loading the model, this model can now be used to make a prediction. So why don't we do that? Why don't we write a function here that that does prediction? So we can say a function that uses a saved model to make a prediction. Path Now, in this case, we could probably steal this code, though, which is going to be model. So by default, the model path would be equal to model path. I don't think we need the image here. We don't classes. Model evaluation. Oh, I see test data predicted. So I think we just need something like this. We just need to say like that here. And we should be able to shift this down here. So we've got classes here, model evaluation, test data, predicted. So let's refactor. Undefined variable test data. So this does get more complicated because the test data download test data from open data sets. So kind of a bummer that code is actually embedded inside of here, which makes things a little bit more complex to play with here, because although that could work, let's see if I just I mean, I guess I could pass in the test data into this. So what if I just passed in the test data, but I could just copy and paste it for now to make it a little bit cleaner. We could just do that, right? So we could do that. If I say make refactor, unused argument, image path. Yeah, we don't need image path at all. So kind of hacking here, but sometimes hacking is good to just get progress moving. Yeah, okay. So now I can just do a another click group that does a prediction. So we can say create a click command that predicts. There we go. We'll just call this predicts. There we go. No, we want to do an option that's a model path exactly. And then we just do predicts. Okay, so let's try this. So let's do slash hello predicts just help. There you go. So if I just do a prediction, does it work? Uh-oh. So we had an issue here. Model eval on line 26. Model eval. So model eval, model path, load, model torch load. Let's see if I did something wrong here. Oh, I think I'm missing this. Loading module. What is this? We need this stuff. What is this? Model is equal to neural network. Model. So I just was invoking it the wrong way. Let's just refactor this. Undefined variable neural network. So where do we get neural network from? Oh, it's here. Boy, this code is becoming more and more convoluted here. Well, I guess we can duplicate it again. So it's going to be hacky, even more hacky code. So we're basically duplicating code, which sucks, but it is what it is. We can throw that up here for now, and we can do. Whoops. Here we go. We can do command. Yeah. So I guess from the beginning, I really could have done that, and then I think we could nuke it. We could nuke it from here. Actually, we don't really need it in there now. Although, oh no, because that's part of it. So we do need that whole thing. So let's see. Back up to this. So we can define this class up here and then shift it to, there we go. Define the model. And then this return, this method, there we go. And then if I refactor it, should let us get away scot-free maybe. Unused argument model path length 30. Unused argument model path, because we just changed this to model path. So really these refactoring tools are just critical, or else it's impossible to know what's going on. So we're cleaning things up a little bit here. There we go. And now if I go back to my predict, we do help. Let's do a predict. Nice, not bad. Predicted ankle boot, actual ankle boot. Now, see, this is doing the predict. It would be kind of cool to make this a little fancier. And actually have the ability to have a test for all. But for now, that's good enough just to get something really, really quick working. Status. All right, so commit, adding predict. Me, this is the way to learn though, is just to take stuff and turn it into your own tool so that you get better and better at understanding it. I would say the only other thing we need to do is saving loading is maybe serve it would be kind of fun to save and load it, transformers, deploy to production. That's always the kind of stuff I'm interested. How does this work? Import it. How do I serve, save and load the module? I guess I could search for like serve model. How do we do this? We just want a hello world serve model here. Import it. We have PyTorch models, serve. Where's our serve? Training, PyTorch serve model. I'm just going to go kind of a hello world, torchserve. Here we go. Quick start. That's what I want. So let's put this into our README. Okay, what we did today was we got prediction, running, and a CLI. So we already did a lot. Can we serve? Let's see if we now we're really making a lot of progress. So torchserve does that. Oh, no, Conda. No. Quick start with torchserve. No, Conda. There we go, pip. So quick start with torchserve, latest release, nightly build, quick start with torchserve. CUDA's optional, latest release. Wow, this is interesting. So do you have to do that? Install dependencies. I mean, let's try it. If I put this in there, what happens? This might be more complex. It might take me a couple of sessions to get this working here, but let's go to the requirements file here. And let's go to MLOps. What do we got going on here? So we have torch serve, torch model. There we go. So if I do a make install, can I get these things cooking? Let's see. Does torchserve install? Maybe it'll work. And then highlighted example. How does it work? Well, this is a good place to stop. So I'll do this next session, which is I will do a lesson 3, which is I got a lot done. I don't need to push myself too much. Get hello world running via torchserve. Next up. So that's next up. All right. Well, this was a good session. See you in a couple weeks.